Okay, so this is going to build on the last video we did, which was determining the number of valence electrons in a configuration. Okay, so one thing that chemists do is that once you've determined the configuration for a given element, you can represent that element with what's called a dot structure. All right, and the reason we do the dot structures, I'll get into that in a little bit later. But first of all, I just want to show you how to construct the dot structures. Okay, so let's first start with the configuration. All right, we'll do sodium, for example. All right, sodium, if you recall, it's got 11 electrons. Its configuration is going to be 1s2, 2s2, 2p6, 3s1. Okay, there's a total of 11. 2 plus 2 plus 6, that's 10 plus 1, that's 11. All right, so what an electron configuration for a single atom, for a neutral single atom is it follows this pattern. It's the symbol of whatever the atom is, and you're going to put a dot somewhere around this to represent the number of valence electrons it has. Okay, there are 8 possible places that you can put a dot, so there's going to be a maximum of 8 dots that can be put around this. So first of all, what I'm going to do is just show you where the possible locations are. Okay, here, here, okay, it goes like this. Okay, so there's a total of 8 possible locations, and the one thing that you should notice is that these locations exist as 4 sets or 4 pairs. Okay, 2 on the top, 2 on the bottom, 2 on the side, 2 on the other side. All right, and notice the orientation that these are drawn. All right, it looks like a colon on the left and the right, but it looks like 2 dots that are next to each other like this. You would never do a dot structure done like that, because when it's on the bottom, they should be side by side. All right, so what the dot structure is it shows the symbol of the element with the number of valence electrons that it has. Okay, so first of all, take a look at this configuration. All right, we need to figure out how many valence electrons there are. Okay, you've got 1, 2s, and 3s. The highest level is 3. How many total electrons are in the third? You start with that 3. It's 1. So you've got 1 valence electron. Okay, so the way you would do the electron dot structure for neutral sodium is you would use the symbol, and then you're going to draw a single dot to represent that single valence electron. Okay, so this is an acceptable dot structure for sodium, but I want to point out that this is not the only way it could have been done. Okay, if you recall, these were all the possible locations. If you had decided that you had wanted to put the dot there, that would have been fine. You could have put the dot here, that could have been fine. Really, the only thing that would not be correct in a situation like this is if you put it kind of down in a diagonal location. All right. Notice that this part right here is kind of a no man's land for dot locations. You want to be able to visually look at the dot structure and be able to say, is that dot on the top, bottom, left, or right? Okay. So that would be sodium. All right. So here's a way that you can think about this. What the dot structure represents is all of the electrons that are not part of the valence level are represented by the symbol. Okay, so just the symbol Na represents the 1s2, 2s2, and 2p6 electrons, and then that valence electron is represented by that single dot. Okay, so let's try something else. We'll just move up the chain. We'll move to the next one, magnesium. Okay, 1s2, 2s2, 2p6, 3s2. Okay, so this is one higher. All right, it's got between 1s, 2s, and 3s. 3 is the highest. These are all the levels where that start with 3. there's a total of 2 electrons in that level, so you've got 2 valence electrons. Okay, so you're going to start just by writing the symbol. Magnesium symbol is Mg. All right, and we need to put 2 dots around it. The rule for where you put the dots is that you only, before you ever put 2 dots on the same side, you make sure each side has at least 1 dot. Okay, so there's several ways you can do it. In general, for 2 dots, you put 1 on one side and 1 on the other. Okay, you could have put this dot here. You know, the difference is whether you're choosing the high location or the low location. So this right here would be acceptable. This would have been acceptable. This would have been acceptable. This would have been acceptable. As long as you're putting a dot on different sides, you're fine. All right. The only way that you get into trouble with something like this would have been by putting 2 on the same side. Okay. The rule is you got every side's going to have at least 1 electron before you ever double up, so you can't do this. All right. So that's magnesium. All right. Let me skip ahead a little bit. We're going to do. Let's do chlorine. Actually, let's do chlorine. Chlorine is 1s2, 2s2, 2p6, 3s2, and 3p5. Okay. 1s, 2s, and 3s. The highest ones are the 3s. Those are the 2. I've just underlined the valence electrons. How many total valence electrons are there? 7. Okay. So for chlorine, you would draw the symbol, which is Cl. Then you need your 7 electrons. All right. I'm going to show you the way to do this so that you don't make a mistake. You're eventually probably going to figure out a shortcut for doing this. So you want to make sure that you have a dot on each side before you ever double up. So 1, 2, 3, 4. Okay. Each side now has a dot. So only now do you start to double up with the locations. Okay. So the electron dot structure for chlorine, you'll notice it's got 3 sides that have 2 dots, and it's got a single side that has a single one. Okay. This is not the only correct way that you could have drawn chlorine. All right. Okay. Notice that this right here has got chlorine, but it's got 3 sides that have 3 and 1 side that's got a single. All right. You also could have done like that, where the single dot is on the side. There's one last one that you could draw where the single dot would be on the bottom. All right. But notice one thing. Whenever you're drawing it, it should appear that the dots appear as pairs. All right. On the sides. All right. The one thing that you want to avoid is something like this. Okay, where if you just were to count, okay, how many total dots do I have around it? I've got 1, 2, 3, 4, 5, 6, 7. Okay, notice the way it looks like the dots have just gotten smeared, spread out, you know, around the entire chlorine. You don't want to have that. What you want to have is an orderly arrangement where you can visually tell, okay, these 2 guys down here are part of a pair. That's part of a pair. This is part of a pair. That guy is all by itself. Okay, so. The one last thing is I want to go over a shortcut for figuring out the number of dots. Okay, the reason that you have the number of dots that you do has to do with valence electrons. So if you wanted to know the reason why does chlorine have 7, do its configuration, figure out the valence electrons, count the number of valence electrons. There's 7. That's why you've got 7 electrons here. Okay, but if you want to use a shortcut, here's what you can do. All right, if you did. Remember when we were doing the electron configurations, we said that there were some patterns in the periodic table. What I'm going to tell you is that everything in this first column here is going to have 1 dot. The second column is going to have 2. the boron column 3, chlorine 4. Let me finish it out. 5, 6, 7, and 8. The rest of the columns are going to have that much. So if you were to just quickly look for, okay, if I wanted to draw the neutral, the dot structure for sulfur, you see sulfur is right here. You realize that it's in that column that should have 6 dots around it, and you know that's how many dots are going to be there. All right. If you wanted to prove it to yourself, do the electron configuration for sulfur just like we did for chlorine. Count the number of valence electrons. It should be 6. All right. So for sulfur, it would just be like that. Okay. Notice there aren't, even though I kind of did this sort of quickly, you'll notice that if you did it correctly, there's 2 that have a pair, and then you have 2 sides that have single electrons here. You could have just as correctly drawn it like this, okay, where you had your 2 single sides away from each other. The one thing that would definitely be incorrect would be to do something like this, where you said, okay, I know I need 6 total dots. Let me do that. Okay, the problem here is you can't double up on any side until you have at least 1 electron on each side. Okay, so that is valence electrons for a neutral atom. The next video we're going to get into figuring out the number of dots for ions.